Hey, good afternoon, ladies and gentlemen. So today we are going to continue working on net ionic equations. I'm going to take us back to what we did last class. So we're going to do a quick review. In our last class, ladies and gentlemen, we were practicing figuring out which of these ions, these are ions because they're charged particles, which of these ions are going to react with each other. And so what we want to do is we want to take out this solubility of common or inorganic compounds. Solubility, again, that's whether or not things are going to dissolve. So this side over here is soluble. This side on the other side over here is insoluble. Soluble means that your hands are going to come apart. So when I'm talking to you in class and I say, oh, what does soluble mean? I don't know if you can see my little picture up there, but it's when things break apart and their hands come apart. Hands together means that something reacts. And so you have two things and boom, they come together and they form a together compound. So they are what's called insoluble. So with that said, ladies and gentlemen, we are going to review that information. So let's just take a look. Remember, if we move this way, we're going to soluble. And if we move this way, we're going to insoluble. Insoluble again means your hands are together, forms a precipitate. Soluble again means your hands are apart. So let's go through that now. So we want to find, we have this solution right over here. And we want to find, do any of these get together? Is there love between any of these ions? So let's take a look and see if there's love between any of these ions. Well, you can see that all of the cation ions are all on the sides, but the anions are all in the middle. It's going to be easier to start with the anions that are negatively charged. So let's start off. Let's take a look. Let's look at sodium or nitrate. Here's nitrate. And let's see if any of these net positives are in the container. And it says right here, no cation ions react, which means that nitrate is always going to be soluble, always. So will nitrate react with anything in here? Absolutely not, because nitrate is always soluble. So now let's take a look and let's look at chloride. So here's chloride right here. And let's see if chloride will react with sodium or with silver. And whoa, the first one we come to right here, if you take a look, the chloride is going to react with the silver to form an insoluble compound. So these two will form an insoluble compound. And the net ionic equation, also known as precipitate reactions, I'm calling it for you guys, would be a silver plus a chloride ion yields HgCl. And there's an S right there. Now, one kid thought that was a number 5. That is not a number 5. Remember, that's a letter S. That letter S stands for solid. Solid. All right. Let's take a look at the next one. All right. So we're going to do the same thing again. Let's just take a gander. Let's take a look at nitrate. We always look at the negatives first. Nitrate is right here. And let's see if the negative reacts with any of those two positives. There's nitrate. What? We just did that one. Nitrate's always soluble. So nitrate will never, ever react in a solution as far as you're concerned. Okay? And so let's take a look at the other negatively charged one. That's going to be sulfate, which is right down here. There's sulfate. Let's see. Okay, that is, everything is soluble. So let's go and look and see if anything's over here. Let's see. Is Na plus over here? That is not Na plus. That is not Na plus. No, no, no. Na plus is not in that box, which means that Na plus must be in that box, which is soluble. So that won't react and form a precipitate. And let's see if Pb2 plus is in there. Whoa, there it is right there. So it looks like Pb2 plus and sulfate are going to get together and form an insoluble compound. So these two will form a compound. And then the net ionic equation is going to be right here. Let me just go color code this for us. All right. Let's just bring it out and make it black in color. It would form, and same thing here. Whoops. Same thing here. All right. It's going to form a an ion. So it's going to be lead 2 plus sulfate yields lead 2 sulfate, which is a solid. That's going to form a precipitate. So let's continue. So that was a review from last class. Now we're going to jump into today's net ionic equations. Now notice it's very similar. Okay, we're going to have a bunch of ions in a container together. So this is the first example I have, and I'm going to leave this one on the page for you. And anything that's in red, you should be able to say, yep, he's going to want us to fill that out. So you're going to have to fill out the end of the products. You're going to want to fill out the balancing, and then you'll want to do this down here, which is the precipitate or net ionic equation. So you're going to need to do 1, 2, 3, 4 things on each problem. Lucky for you, I'm doing problem number 2 for you, and then you only have to do 3 problems after that. So the directions are up here at the top, all right, but I'm going to take you through it right now. I'm going to work this one out for you. So let me get that one going for you. Now, I've enlarged the screen a little bit, but you can still see that I have my solubility table. Okay, so we're just going to take a look over here. Now, very quickly, we have this word aqueous. This little AQ. Remember, AQ means the things are broken apart. So it means that sodium and sulfate are already broken apart. Aqueous means these are broken apart. You never even have to look it up. But if you wanted to, we could come over here and say, Mr. Pepe, just double check with me. And I'll be like, okay, here's nitrate. Nothing reacts. Everything is soluble. Here is sulfate right here. And sodium is not in that box, which means sodium is over there as well, in which case you can say that they're both soluble. So the first thing you're going to want to do is we're going to break these apart, because since it's aqueous, we want to know what does it look like in solution. You can see that might disturb someone, so I'll just kind of put it here like that. There we go. So we want to break these apart. There's 2 sodiums, and you can see that each sodium, is there an Na+? There's an Na+ right here on the screen. All right. You can see, oops, get rid of that little thing there. I hate when these little things show up. I don't know how to get rid of them. Well, whatever. You can see there's a little Na, and that's an Na+ right there. So you know that our NAs are going to be Na+. You have this on your screen, so you don't need to worry about it. All right. So we're going to break these things up into their component parts. So we're going to have an Na+, another Na+, because there's 2 of them. We're going to have one SO4 2-. And then this one that's over here is going to break apart into Ag+ and NO3-. Now, like we had before, where we had one container, you have to imagine that we're going to take these 2, this says plus, and we're going to put these 2 containers together. So you don't have to draw this, I'm just doing this for you. We're going to have sodiums, we're going to have sulfates, silver ions, and NO3s, all in the same container, because we're mixing these 2 things together. That's what plus means. And we want to know, will any of these things get together? Well, if we review and we take a look at nitrate, remember, nothing ever reacts with nitrate. So nitrate's going to be out. So nitrate's not going to react. It's going to just stay floating around. Sodium also isn't going to react. So those are out. So let's just look and see if the silver and the sulfate reacts. There's sulfate. And let's see. Is Ba2 plus silver? No. Is strontium silver? No. Pb2 plus, is that silver? No. But there is silver right there. So you can see that the silver and the sulfate, these 2 are going to get together and form an insoluble solution, a precipitate. And remember, that part down here is the precipitate. Now at this juncture, all we have to do is draw everything out, which is going to be in red. I've made everything in red for you. So what's going to be the solid? Well, the solid is going to be Ag. Now notice it's a +1 charge. So that's Ag plus and SO4 2 minus. These are not balanced, so we're going to need 2 Ag pluses. Some kids are like, well, where do you get it from? You know what? There's billions of them in this solution, but we just simplify it and just show a couple of them. There's an Ag, so we're going to need 2 Ags, 1 SO4, and it's going to be a solid. Now that's what's reacting, those two. Now, is there anything else still floating around that didn't react? Yes. What didn't react? The nitrate and the sodium didn't react. So we're going to say, well, these two things, since they didn't react, they're still just floating around inside the solution. So this is what our picture looks like at the end. The silver reacts with the sulfate to form this solid down here. And then the sodium and the nitrate are still floating around, aqueous, just like Ag and NO3 was floating around earlier. Now at the end, we want to write this all out. So we usually always, or I ask students to always start with what forms. So Ag2, oops, I didn't leave myself much space there, so we'll have to balance it. All right, so Ag2, SO4, solid, plus solid, plus NaNO3, and then that, ladies and gentlemen, is going to be aqueous, because aqueous means they're still floating around a solution. So we're pretty much done right here. We can balance this out and say, well, there's 2 sodiums here, and I'll put this in a different color so you can see it. So there's going to be 2 sodiums there. 1 sulfate here, 1 sulfate, good. 1 silver, 2 silvers. We're going to need a 2 there. Lucky for us, 2 nitrates, 2 nitrates. It balances out. 1, 2, 2, 1. 1, 1, 2, 1, 2. Now, once you finish that, we need to write what the precipitate reaction was. And that's going to be Ag plus silver ion plus the sulfate, the sulfate yields Ag2 SO4 solid. All right, I'll draw this in green so you can see the arrow. So the sulfate comes down here. The silver is going to come here because I like writing the pluses first because the plus ones always go first. And then that's it. What do we write with the Na and the NO3? We don't write anything because they're aqueous. They're not involved in our reaction. So the important stuff we're taking out right now is all written in red. So all of that's written in red. You do not have to write any of this. I just wrote it so you can see my thought process. All right? And this wraps it up. You're going to have 3 more of these. Lucky for you, this is the first example. I just gave it to you. All right? So we're done right now. If you have questions, I'll be here in class. I know that some of you are still struggling with breaking things apart. You might want to go review our Unit 9 lesson and then even go all the way back near the beginning of the year when we're doing naming called nomenclature, and that's going to help you break some of these things apart. And just understanding that NaCl is going to break apart into Na plus and Cl minus, or I don't know, silver nitrate. Aqueous is going to break apart into Ag plus and NO, that's a 3, and that's an N, NO3 minus. Again, it just takes practice. You're just learning chemistry. So after we do this activity, we will be doing a lab today. So enjoy, and I hope this all makes sense to you. So please let me know if you have any questions.